Yes, good morning, class. I'm audible to you. Yes, students, let me know I'm audible to you or not. My screen is visible.
Yes, sir.
Okay. So we will start in couple of minutes. Let the student join us. And you have to mark your attendance by writing present in the chat box, right? So as we are discussing in the previous class, which service is better uh, among TCP or UDP, right? One is connection oriented and one is connectionless. So this was the discussion in the previous lecture, right? And we are understanding that both services are important and it depends upon the type of application, and according to that we are going to adopt the service, right? So none of is superior as compared to other, but yes, talking about reliability and unreliable connection, then we have to make our choice between these two, right? So where TCP is a reliable communication and UDP is a unreliable communication, right? Where we have understood that this is much faster as compared to TCP. So this one is slower, right? And the reason for that is because it required certain time for establishing a connection, right? So it required certain time to establish a connection between one end to another end. So what else we can say about TCP? It is an end to end communication, right? Right. So in this we need to reserve the resources, right? Because we are establishing a virtual path. So a virtual path will get established in this, right? So there is no virtual path in this. No need to do that, right? Immediately sender can transmit the datagram. Over here we are talking about datagram, right? And on the other side TCP we are saying streams of bytes or streams of data, right? Streams of data will be transmitted in that virtual path, and even we are not breaking the breaking the sequence, right? Sequence will remain same. The sequence of flow of data will be same and delivered in a same manner on the receiving side, whereas the sequence is not same because they are following is not same because they are following different path, right? So that basically leads to fast communication, right? So this is a lightweight, you can say, kind of protocol, right? Whereas this is, you can say, it is a heavy protocol because it required resources, dedicated resources. It reserves the resources till the end of the communication. It does not require any kind of reservation for the resource, right? So resource will not be dedicated between the source and destination, right? So in this limited connection could be established. This need to be understand. Limited connection, right? In this we can connect any n number of user because we are not bounded with the number of resources available to us, right? So this was the takeaway in the previous lecture that we have discussed. So I will move further where we have ended in the previous class, right? And if you have any doubt in the previous lecture, you can ask me, right? Please don't feel shy, and any kind of doubt if you have, it's coming in your thoughts, please ask me, right? So this is what we are talking about precisely. We have segregated them into protocols, and connection oriented service is known as TCP, and whereas connectionless service is known as UDP, right? So what is the full form of TCP? That is the transmission control protocol, and UDP is user datagram protocol. So that's why the data that is moving inside the network in connectionless service is known as datagram, right? So we have talked till here that UDP is faster, as you can see, and TCP is a slower than UDP, right? Where you can see retransmission of lost packet is possible, kind of reliable communication. So TCP is a, please note it down, TCP is a reliable communication, and UDP you can say is a kind of unreliable communication, because we are not performing this type of activity again. No retransmission, right? Where you can see this protocol is in heavy weight because it required more header length as compared to UDP, which required less header length, right? So that complexity reduce the demand of resources, right? So it required less resources, whereas it required more resources as compared to UDP. So where in UDP is lightweight, which required less resources, right? And one more thing we have understood in the previous class, that TCP does not support broadcasting. Why so? Because it is maintaining a dedicated path between source and destination. That's why it is called end-to-end communication, right? So in that way, we could not able to communicate with the other devices which is available in a network. Let me show you in a pictorial way. You can see in this particular diagram, you can see that once the route is decided between source and destination, that is R1, R2, and R4. Now, in broadcasting, what we are saying that we have to disseminate the packet in all direction. But since we have restricted to move in this dedicated path, how we can able to forward the packet in to the other nodes, right? That is not, so you can say this is a kind of tunnel, right? This is a kind of virtual tunnel which has been established between a source and destination. So packets are bounded to move in this tunnel only. So broadcasting is not possible in that way, right? Whereas on the other side, you can see that packets are not restricted to move in any tunnel way. They are allowed to move in any direction. Some are moving in this direction. The only goal is to reach to the destination as faster as possible, right? So that is the goal of this protocol. So that's why they are allowed to move in any direction, right? Depending upon the available bandwidth, this packet will decide, and they will make their destination, right? So they can reach to their destination. So in that manner, we are saying that if we are using UDP, then we could easily able to do broadcasting, right? So over here, packet could be forwarded in this direction. So if nodes is connected to this, so we can perform broadcasting. If more nodes are connected like this over here, so since packet has been received over here also, so we can broadcast it, right? So that is much easier, right? In some application, try to understand, we need to deliver the packet to each and every node available in a network, right? That is a need of require or need of that application, suppose. So in that way, I'm saying that connection oriented service will not able to perform, whereas service connectionless service will easily able to perform because of the its way of communication, right? It has that inherent property in it, because packet can able to deliver to the neighbors, right? Whereas in this, it is delivered to the decided neighbor. So once the tunnel is decided, R1, R2, and R4, so it is now decided. So they are restricted to move in that decided neighbors only. Whereas in this case, there is no restricted neighbors, there is no decided tunnel. we are connected to every other node. Packets are allowed to move in any direction, and the goal is to reach to the destination as much as possible, as fast as much possible, right? So that was the point which is talking about why that TCP does not support broadcasting, right? This is the question that may come to you in your MST. Why 5 marks question, right? And why it is so in UDP. So why TCP does not support broadcasting, whereas UDP support broadcasting? Explain with the help of example. This question may come to you for your MST 1, right? So please note it down. This is an important point. Now, moving further, you can see these are some examples. So question may come to you, discuss or give some example of TCP protocol. So immediately it should come in your mind, HTTP protocol, HTTPS, that is hypertext transfer protocol, secure, then file transfer protocol, simple mail transfer protocol, SMTP, in which connection is established before transmitting the packet, simply and similarly telnet, right? Which in this also we establish a connection before transfer of packet, right, or stream of data. So that's why these are the some example of connection oriented services, that is HTTP, HTTPS, FTP, SMTP, and telnet, right? We will discuss in detail all this protocol in the last unit, because this is in our last unit, in which we will talk about their working, their role, responsibility, why this protocol are designed. Every protocol are designed because of some reason, and they have some role and responsibility, and they are separated from each other with a unique code that is known as port number. So please remember that every this protocol, this in this last P basically stands for protocol. So this protocol, they have a unique port number, and with that we can easily identify them from all the services, like 8080, right, like 21, 23, SMTP 23, FTP 21, 8080, HTTP. These are the port number which is reserved for this particular services, right? So that we could able to run in when we are creating a server. Remember this part, right? And if time allow us, in the end, I will definitely, if you are interested, then I will show you how we can create our own HTTP server, FTP server, SMTP server also, right? So that could also be possible. In the other side, you can see we having domain name server, DNS, right, which basically resolve the name and IP. As we understand earlier also, that it is very difficult to remember that that decimal number, IP address, 32-bit address, 192.168.1.1, right? 2-3 addresses you can easily understand, but what about there are thousands of websites available in the market? And now I'm asking you, tell me about Facebook, tell me about Twitter, tell me about YouTube, tell me. And it is very difficult for someone to remember all the IP address. To resolve that problem, we have this protocol, we have this service that is known as domain name service. That's why, and that is what connection less service, which required a kind of broadcasting stream in it, right? So that's why. So what is that? It basically maps IP address into name and name into IP address, right? So I'm just giving a small brief of all this protocol, so that it should not be like you are not getting what these are, but yes, you have to make clear in your mind that these are some protocols which are segregated based on their orientation, right, based on their service. So these are connectionless and these are connection oriented, right? And I'm talking about DNS, where DNS is a service which basically help us to resolve this IP addresses into name and name into IP address. So this is known as forward zoning and reverse zoning. This property is known as forward zoning and reverse zoning, where name is translated into IP and IP is translated into name. Now, this is the benefit. Now we have to remember only the name of that server, like www.google.com. Otherwise, few years back, we have to remember by decimal number like 192.168.1.123 like this way. So many servers, so many addresses are there. So it is very tedious. It is very difficult for us to remember all the IP address, right? It also become a challenge sometime. So if suppose there are 100 server, how to remember all that 100 IP address? It is not feasible, right? So to provide a service in which it helps the user to remember with its name, right? Such as Google. Now we can able to remember 100 names easily, like Facebook, Twitter, Google. We have IM, lots of there. So simply we Google it and we get that address, and we could able to connect with the server, and simply we can solve the query. So for that reason, this DNS domain name server was created, right? Otherwise, you can see this is known as dynamic host configuration protocol. So this protocol was designed for the purpose for administrator, right? Now you can see where lots of devices are there in a lab, and now we want to configure it by assigning it an IP address. As we have learned in the network lab also, that we have to assign an IP address, otherwise we will get an error, no functional port, right? So if we are having more than 1,000 system in a lab, then you can understand the headache for that network administrator to assign without making any mistake, to assign the IP address without making any mistake, right? So it is very difficult for that person, right? So in that sense, this protocol was designed, and that is known as dynamic host configuration protocol, which help us to allocate the IP address automatically. I will show you actually, but this is not in our practical, but I will show you in packet tracer that we will design a server HTTP DSCP server sorry, that is dynamic host sorry, that is dynamic host configuration protocol, in which what we will do, we will assign a pool of IPs. Try to understand this thing, pool of IP address, to easy the task of administrator, nothing else. The purpose of this protocol is to easy the task of administrator. Otherwise, that administrator has to visit each and every node, and manually he has to assign the IP address to all the nodes, right? So that will become a tedious job for him. And to minimize this thing, what we did is we design a server that is known as DSCP. Now DSCP will allocate IP address automatically whenever any device in that LAN, means it could be a palm top, it could be your desktop, it could be your laptop, any device that startups in a network in that LAN, that device will demand for an IP address from that DSCP server, and then this DP server will assign the IP address. So the task of administrator is now reduced because of this DSCP server, right? So I'm not going in detail, just to aware you about this thing. Rest we will discuss this thing when it will be in our lecture, in our according to the chapter, right? So moving further with this discussion now, just hold on, and I have to take a screenshot. And those who have joined me late, you are requested to mark your attendance by writing present in the chat box. Meanwhile, if you have any doubt, you can ask me. Okay. Let me clear the screen for you. Now, this is connection oriented, connectionless service, right? In the previous, we have seen the protocols of connection oriented and connectionless, right? These are the protocol of connection oriented, connectionless. Now, talking about if 2 marks question is there, then you can say that what is the difference between connection oriented and connectionless service. So as I told you, this is end-to-end connection, whereas it does not require any establishment of connection. This is a virtual path. This is not making any virtual connection. Higher bandwidth is demanded, lower bandwidth is in it could able to work, right? In low bandwidth also, this service could able to work, right? Whereas there is no congestion, because there is no traffic between sender and receiver, right? So the traffic is their own packets. No other sender and receiver traffic is coming in between. So we can say there is little congestion, or you can say no, very minimal, right? So that's why there is very less collision also in that way. But in this way, you can say, in order to utilize the bandwidth in much higher way, we are transmitting a packet in any path, right, to reach to the destination, and it also support faster transmission. But what is happening because of that? Other nodes datagram is also coming in between sometime, and due to that there will be a congestion, and congestion leads to collision. Try to understand this thing. Whenever there is a congestion, then there could be a chances of collision or accident. Just understand, you are entering to a market with heavy traffic. Now the chances of getting collide will be much higher. You cannot able to imagine that from where the packet are coming, and due to that or the vehicle is entering, right, from different direction. So more traffic means the chances of congestion and the collision will be higher, and that's why it is saying in this way, right? So there can be congestion and due to not providing an end-to-end connection between source and receiver, because we are not establishing connection end-to-end as we are doing over here, right? End-to-end. And it is dependable connection, since we are establishing a connection. So it is dependent on that establishing and disconnecting, and then it is transmitting. Whereas uh, here, if receiver is not willing to receive, then sender could not able to send. So that's why it is sent. That's why it is said it is a dependable connection, right? Because if receiver will say, okay, I am not ready to establish a connection, then sender could not able to start transmission. And that's why we are saying it is a dependable connection. Whereas in this, there is no such permission is required, because we are immediately transmitting the message, right? And in that way, it is not a dependable connection, right? So we are not dependent service, because it does not ensure the share of data packet from one end to another for supporting a connection, right? So that was a all about connection oriented and connection service. Now in future slide also, whenever this connection oriented and connectionless service will come, I will not going to discuss all these aspects, because I have discovered it in very much detail, right? Even if you have, if want more discussion on this, we can have a special session, and we will discuss on that, right? So this is one example which I have already discussed in the previous class, that one of the kind of live example, that if you want to reach to your neighbor or your friend which is living in one side and on the other side of the river, right? So in that way, how you could able to transfer your message. So the one way is you will make a bridge over that river, and then it can be delivered, right? And the other way is you can get it delivered through some aerial way, right? Or you can say through birds, or through drones, you can make use of them, right? In that way, this is one way we can say. So this is connection oriented, where we are creating a bridge, right? Establishing a connection between source and destination, and that is end-to-end connection. That's why this is the solution, and this is known as connection oriented. Whereas this one will be, and now in the aerial way, you can say there is no fixed path, it can move in any direction, and the fast this is more faster as compared to the above one. So this is your connectionless, right? This is just an example to you for understanding, right? Okay, now moving further with the connection oriented services primitives. Now what are those primitives? Try to understand. These are some primitives you can see that we need to do before transmitting the data, that we have to listen to the connection. So if sender is there on one side and receiver is there, so you can see when there is a request, right, for establishing a connection, right, then on the receiving side, what we need to do, we have to listen, right? So we are waiting for incoming connections. We have to make this provision. Then only we could able to understand that, okay, there is some request which is from some XYZ person want to send some data. So listening need to be there. So listen for that connection. In the same way, if this is a sender and the receiver, then listening need to be there, right? Then after listening, if this is available, this receiver is available for communication, then what it will send? It will send a approval, and then there will be exchange of some information between these two devices, and that basically make connection establishment. So what we will say, the next primitive you can see over here, which talk about that connection will get established with a waiting peer. So this is one peer and this is another peer, to peer, you can see peer-to-peer network. So connection is now established, right? So this is the second primitive, connect, right? So they will connect with each other to establish a connection. Now you can see accepted the incoming packet over here. It also accepted the incoming packet, right? Now it will receive the message, right? This is the next primitive. Now some information that need to be there, right? Accept करना है signal को, approve करना है हमने connection को. For that we are using this primitive. Then it is received, right? And you can say that is received, right? Then we are sending the data, right? Send a message to the peer. Now sender will send a message to the peer, right? To send a message to the peer. This is a peer, right? One peer, from one peer to another peer. And then finally, when it is over, what we will do? We will disconnect all this connection which we have established just now. So that's why we are having this 6 primitive. Please remember this thing when we are talking about connection oriented services, right? So just remember, you could be asked like in this way, 2 marks question. Discuss the service primitives for connection oriented service. So you have to list them like listening, connection, accept, received, send, and disconnect, right? In this manner we will do. So receiver can use this primitive anytime, right? Disconnect, right? Any peer can do that thing. Sender can also disconnect or terminate a connection at any time. So no one is bounded with anything. Receiver can also terminate at any time, right? So receiver can send the request whenever it is required, and now it depend upon the sender can send the request at any time. Now it depend upon the receiver who will accept it or not, right? Once it is accept, then they will continue with their sequence, that first they will listen, then there will be establishment of connection, there will be acceptance, then they will be received, then message will be sent, and then when the acknowledgement will be over, after that they will disconnect the connection, right? In this manner the chain will continue. This is how that communication will take place, right? This is the service primitive, right? Now in this way you can understand it more better. Let me clear the screen for you, and if you have any doubt you can ask me, right? Just hold on. Okay, so as we have understood that this is one AND and this is another AND, means that peer and this is one more peer on the other side, or you can say this is your client. It could be one client, right? It is a server, right? So a request could be sent from the client machine, right? So that's why it is said so you can say this is a sender and you can say this is a receiver, right? Server is a receiver, right? So these are the primitives that you can see how it will take place. Receiver. Now you will see the first thing that there is a connection request between the sender to the receiver, right? As we have seen that we cannot able to transmit the data immediately in case of connection oriented service. And how we can do? First we have to take the permission that okay, you're listening or not. So you can see this is a part of your operating system, right? And these are the system call where is this is one process, right? And if you remember, I have told you actual communication takes place between process which is running in one system to another process which is running into another system, right? So you can see over here, this is one process, which this is a client process, right? Now suppose this is your HTTP protocol. So that's why I can say HTTP hypertext transfer protocol, 8080 port number. This is how we can able to recognize this thing. Now this server will have this port number over here, 8080, on which port this service is running, that is known as HTTP, which is known as one process or program which is running over here, right? Now you can see in this is a reserved port number of the server 8080. So client will also have some port number over here, right? So client will follow its own port number, something like 50 because as we know the maximum limit of a port number is how much? 2 raised to power 16, right? And maximum number of IP address that we could have is 2 raised to power 32, right? So this will be maximum how much? 65,500 and something, right? 35. So this is the maximum limit. Now we will saying that there will be a random number by client, because this is a client service. So client will generate a random number between this range, right? Not less than 1024, because these are the reserved port number for all the servers, right? So we cannot make use of them. These are reserved for servers. Like 80 is reserved, 21 is reserved, 23 is reserved, so on 1024 till 1024 it is reserved. After that it is we have to pay for it, right? So and then we are left with some more which are unreserved and used for this random, right, numbers. So here we have a random port number, and with that random port number we will distinguish this service, this process, right? So now that request will be sent over here with this random number, right, to this to this server. So here we have shared that this one here we have shared that okay, this process want to establish a connection to the server. Okay, now in that manner server will accept and response, okay, I am available and this is my IP address, right? So this will be along with IP address and random port number. So this combination is known as socket. Please remember this thing, right? Similarly, IP address and port number, this combination is known as socket. So there is a connection establishment now, right? Now it will request for data from the server. Client will come to know that okay, connection has been established. Now what will required? We require some data from the server. So server will look into and then it will reply to that data, right? And after that there will be a disconnection. So client will say, okay, I don't want further communication, I am going to disconnect. Similarly, the connection will disconnect from this side. So these are the steps which is involved, and you can see this disconnection could not be possible till we have established the connection. right? So this will come after that only, right? So that's why the numbering is given in that way. One, connection, acceptance of connection, request for data, reply for data. Then as a reply for data acknowledgement or that thing is over, then there will be a disconnection of service between client and server machine. So these are the primitives. Please remember, question may ask to you, what are the 6 primitives, right? Or that we have seen in the previous slide, right? This one: listen, connect, accept, receive, send, and disconnect. So these are a simple connection oriented service and between client and server model, right? Yes, any doubt, class? If you have any doubt, you can ask. No doubt? Please let me know. Those who are have joined me late, you are requested to mark your attendance by writing present in the chat box, right? Okay. In today's lecture, we have covered 5 to 10 marks question from MST point of view, right? That connectionless, connection-oriented service, TCP, UDP, and what are their difference? Which one is better? And what are the primitive services? 6 primitive services are there, and how they establish a connection between client machine and server machine, right? Question may ask to you in that way. Explain